students, here's a review for your semester one final. We'll break it up into two parts: the non-proof things, and then the proofs. For this review, you can just remember that if you need any additional study material, you can see the learning targets are up here, the chapter, and then the learning target. So you can go back and find some other things that would help. First thing you're going to see on this test is either the segment addition postulate or the angle addition postulate. Both are roughly the same thing. You're just going to add up the pieces and make them equal to the whole thing. So in this case, I've got 14, and then add that to 3x minus 4. That's where this comes from. And then set that equal to the entire thing, which is 4x plus 4. And then we combine our like terms. 14 minus 4 is 10. Then we put all the x's on one side. Subtract the 4, and that's how we get x equals 6. But don't forget, you might need to go back and plug that in to find an actual length. So this says find the length of NP, which would be this one. So I plug it into 3x minus 4, 6, that is, and I wind up with 14. All right. Using a protractor, just one of the basic skills you got to be able to have in order to survive geometry. And so here, obviously it's obtuse, it's greater than 90 degrees, and you just measure that out. One of the tricks that I have people do is just use a straight edge to extend that line so they can actually measure it all the way to the dash marks. For learning target 1.7, you're taking a look here at the angles. So you got BJA, that would be this angle right here, and then AJG. Well, yes, these are adjacent. Yes, they're supplementary, but the most specific way of saying it would be a linear pair, since they're adjacent and supplementary. Then angle CKL and DKE, those would be these two angles right here. You can see we make two straight lines. They cross, and these two are opposite of each other, so those are vertical angles. And then BAJ would be this one right here, and JAG. Well, these are adjacent. They're two angles right next to each other, but they don't make 90 degrees, so they're not complementary. They don't make 180 degrees, so they're not a vertical pair, or sorry, a linear pair. So they're just adjacent. All right, moving on to the second section. For learning target 1.8, we're talking about supplementary and complementary angles. So if we've got 90 degrees right here, that means that these two have to be 90 degrees. And so if we add these two things together, it would have to be equal to 90 degrees. So I combine my like terms, get 5x, I add the 10, divide by 5, and I get 20. All right, using a compass and straight edge, construct an angle bisector. Well, we've had a lot of practice with this recently with the in-center and circumcenter and all that. So here, you just have to, at any length, draw an arc across your angle. And then from this point right here, put the pointy edge. From this point right here, put the pointy edge. And then draw your arcs out in the middle. The place where they cross is the key point, and we just line up from our vertex here through there. All right, real simple. Find a counterexample to disprove the conjecture. In this case, it says 3 points make a plane. Well, just draw a simple little picture where 3 points don't make a plane. And of course, the example here would be when you got 3 points that make a line instead of a plane. Okay, converse, inverse, and contrapositive. Our statement, if x is odd, then 3x is odd. Well, that is a true statement. You can come up with a number of examples for x being odd, and if it is, well, like 3 times 1 is 3, that's odd. 3 times 3 is 9, that's odd. So that's true. The converse, remember, you're going to switch them. So the if part goes for there, and then the then part goes here. So if 3x is odd, so this whole thing right here, then x is odd. And you have to determine whether or not that's true, and I hope that you remember that if the converse is true, then the inverse will be true, and vice versa. Now, to be honest, this one's a little bit confusing for me to read. So I'm going to take a look at the inverse. Well, the inverse, you're going to keep it in the same order as up here, but you're going to negate it. You're going to write the opposite. So what's the opposite of x is odd? Well, x is even. So if x is even, then 3x is even, the opposite of being odd. And for this one, this is much easier for me to understand. If x is 2, then 3x is 6. That's even. That's a true statement. And so this is true. And so I know that if the inverse is true, then the converse also has to be true. The contrapositive, you're going to do both things. You're going to do the converse and the inverse. You're going to switch them and negate them. So I say, all right, if 3x is even, then x is even. I switch them and I negate them. And again, this is a little bit weird for me to think about, but I know that the original conditional is true, and the conditional and the contrapositive both have to be the same, always. So if this original one were true, then the contrapositive is also true. All right, moving on to the second section. Use the law of syllogism. So this is like the transitive property. You made your books about this concept. So I've got if x is greater than 5, then 3x is greater than 15. So if the next one starts with if 3x is greater than 15, which it does, then I can continue my law here. Then the Seahawks will beat the Cowboys. Okay. If I start with if the Seahawks beat the Cowboys, then I can continue with my law of syllogism, and I do. Then Mr. Carlson gives all A's on the final. Well, yeah, I've got these connections here to here, here to here. So that means I can conclude if the beginning, if x is greater than 5, then the final thing. Mr. Carlson will give all A's on the final. All right, learning target 2.11. Just going ahead and using the vertical angle theorem. And that just basically sets up this being equal to that. They even look equal, so you could use your common sense even if you forgot the vertical angle theorem. But I set them equal to each other. I subtract the 7x from both sides, and I add the 2, and I get x equals 3.5. All right, find the value for x that makes a parallel to b. Well, you know, when we had parallel lines cut by a transversal, most of the time we had to set them equal to each other. With alternate interior, alternate exterior, and corresponding, you would set the two things equal to each other. But there was one case that was a little bit different than the others, and that was this case, where you had same side interior. And when you had same side interior, they were supplementary, meaning I added them together and I set them equal to 180. You can even look at it, and they don't look equal to each other. So I add them together, I combine like terms, I subtract the 76, I divide by 13, and x equals 8. 8 is the value for x that would make A parallel to B. All right, using the triangle sum theorem, if I need to find x, I would need to find this. But if I was going to find this, I would need to find this. So I use the triangle sum theorem here, 90 plus 39. Subtract that from 180 and I get 51. Because this equals 51, I can add it together with this, and because this makes a straight line, I know that also is 180 minus these two things. That gives me 79 here. Now I've got the two values. I can use the triangle sum theorem again. 180 minus 79 minus 56 would give me 45. Okay, on to this section. The exterior angle theorem, the EAT. This was another one where it was a little bit different. The exterior angle theorem says that the exterior angle is equal to the sum of the two remote interiors, so the two farthest away from this angle. And, so that's where you see this formula. The exterior angle, 4x plus 8, is equal to the sum, 51 plus 2x plus 3, the two remote interior angles. I combine my like terms. That's where I get the 54. I put all the x's together. I subtract 2x from both sides. That's where this 2x comes from. I subtract 8, divide by 2, and I get x equals 23. All right, here's another construction to construct a parallel line. So first thing you're going to do is just from B, just draw a nice line through B and your line that you want to draw a line parallel to. It doesn't matter the angle, just draw one through there. And then you're going to put the pointy edge of your compass here and just draw an arc. Doesn't really matter how far away it is. And then from B, put the pointy edge here using the same length. Go ahead and draw an arc. And then measure your distance from here to here. So open up your compass to make that length. And then put the pointy edge right here. And then draw an arc here. That'll make an intersection point right here. And then go ahead and draw your line through B and that little intersection point. All right, this was everybody's favorite thing to do when we were doing orthocenter, but this is all the stuff you did, but without the orthocenter part. If I want it perpendicular to this line, I want the slope that's the negative inverse of this slope. So the opposite of 2 is negative 2, and the inverse of 2 is 1/2. So I have negative 1/2, that's kind of the key here, and I want to go through the point 6, 2. So I'm going to use 6 to plug in for x, 2 to plug in for y, and then I just go ahead and solve for b. Half of 6 is 3, so this would be negative 3. I add 3 to both sides and I get b equals 5. That's the y-intercept of the line that is perpendicular to this one, that goes through this point. And so I finish it off and say y equals negative 1/2 x plus 5. All right, using the isosceles triangle theorem, you're going to write and solve an equation. Well, remember with isosceles triangles, and here you know it's an isosceles triangle because the base angles are congruent. Well, you know that the two sides are going to be congruent, so I set them equal to each other. I put all the x's on one side, I subtract the 4, and I get x equals 1. This one does ask me to find the length of AC, and so I'm just going to go ahead and plug that in for here. 8x plus 4 becomes 8 times 1 plus 4, which gives me 12. All right. On to the last section for non-proof things, the triangle mid-segment theorem. Remember the key here was the mid-segment was half of the base, so you needed to double it in order to make them equal to each other. So that's why I multiply by 2, and then I just go ahead, use the distributive property, put all the x's together, add the 10 to both sides, divide by 2, and I get x equals 6. It does say find the length of AB, so I plug 6 in here, and that's where I get the 19 from. Okay, over here you got to make sure that you are actually proving the thing that I'm wanting you to prove. And so in this case, I'm asking you to prove the distance. So I use the distance formula. If I asked you to prove that they were parallel, you would use the slope formula and show that the slopes were the same. So make sure that you read the question and do the right part. If you want to be safe, do both. Anyhow, in this case, you want to show that the distance is half. So I found the distance of DC using the distance formula. Square root of 10 is about 3.16. And then the distance of AB, found that that was the square root of 40, which is about 6.32. And so CD is half of AB, well, because 3.16 is half of 6.32. All right. Construct the circumcenter and then the circumscribed circle. So this was the perpendicular bisectors. So you're just going to do the stuff for perpendicular bisector. To get this red line, do it again over here to get that red line. And then you didn't have to do any other things, you just had to take the circumcenter, extend your compass out to one of the vertices, because that'll be the radius of your circumscribed circle, and then just draw it around. Okay, triangle inequality theorem. You just add all two things together, make sure they're bigger than the other one, and that's the case for all of them, so yes. The triangle inequality theorem to find a range, well, here you're just going to add, you've got the case where 21 could be the longest one, so add the 12 plus the mystery side. That's got to be greater than 21, so that means x has got to be greater than 9. Do the same thing over here, but with the mystery side being the biggest one, add the two things together, and so that's got to be greater than the mystery side, so x has got to be less than 33. Make sure you put it in appropriate compound inequality, and that's it for the non-proof part of your test.